Hello everyone, welcome to the next lecture on the MH set PY question series. Today I will explain you how you can solve the MLE estimators question. Myself Dr. Harish. You can simply follow my YouTube channel where you can find the playlist of the CSR UGC net, and the last lecture was on the PY question of the Markov chain. Apart from them, you can also see the various lectures related to the mathematics and the statistics in this playlist. There is one more playlist you can see, PY question of the IIT JAM, and I already explained the gate and the IIT JAM of the PY questions related to the MLE, unbiased estimators, UMV, and many more are there. You must watch these lectures before going to any of the examinations center. So what is the MLE? So before I directly start to the PY question series, let me quickly recall you what is the concept behind that. MLE is a technique which are used to estimate the parameters of the given distribution. What kind of the distribution you have? For example, if you have the binomial distribution, how many unknown parameters is n and p? If you have the exponential distribution, then how many unknown parameter? Only one. If you have a normal distribution, how many unknown parameter you have? Two. And similarly for the other distributions. So the target of this MLE is to estimate these unknown parameters based on the random samples. So that's the purpose of the MLE. Or you can say our target is to maximize this log likelihood function. And this f is either called as a PMF or it is called as a PDF, depending upon that whether your random variable x is my discrete or continuous. Now, how you can maximize something? That is the first derivative to be 0 and second derivative should be less than 0. But because of this product sign, it is not an easy task for us that you can differentiate this. So in order to handle this, we always use this log function. And again, this f will depend upon the discrete and continuous case. Now simple concept about that I can solve for you each question with the help of the 10 to 15 second time period. You must watch this video till the end and you can learn many shortcut tricks. I hope you can like, comment and subscribe my YouTube channel as well. Now let's start with the first PY question which is recently asked in this MH set examination. You have to read the statement very carefully. If one observation n is equal to 1, if one observation is obtained from the Bernoulli distribution, and we all know the Bernoulli distribution has only one parameter p, then the MLE of the p. So what is the tips for you? Whenever x will follows the Bernoulli distribution, then what is the MLE of the p? MLE of the p is my mean of the x. Similarly, if I say x follows my binomial distribution with the parameter n comma p, then the MLE of the p is always with the mean of the x. Fine. So what is the answer of this? Mean of the x is summation of the x divided by n. But in this case, n is my 1. So what is the answer of this? So what is the MLE of the p? Only x. Because sum is my only x divided by 1. So the right answer is A is my right answer. And you can see how many seconds you are needed to solve this problem. Okay, look at this another one. If xi's are my independent and identical, that means IID. Xi's are my IID, uniform distribution over minus theta to plus theta. Then the MLE of the theta. Can you write the PDF of this? PDF of this will be 1 over 2 theta. So firstly, I will give you the tips. If the PDF is free from the unknown parameter, if f is free from the say theta, then the MLE is not unique. Fine. And if it is dependent on the theta, then MLE is my unique. And you can see it is not free from theta. That means MLE is my unique. Now, what is that? This x1, what is this xn? These are my ordered statistics. So whenever we are talking about the ordered statistics, you always convert this whatever the range are there to be the positive sign. Your first target is to convert this limit to be the positive sign. That means this is given to you. How you can convert this into the positive sign? I can simply say this number. Fine. Now, once you can obtain this number is my positive. Fine. Remember, once you can obtain this number is my positive, then that means this is my mode of x. Fine. So that means your MLE will depends on the mode of x. But what is the xn? We all know xn is my maximum of x1, sorry, MLE of maximum of x1, x2 and so on. But we need a mode of x, but it is not dependent on the mode. Cancel out. Since xn is not dependent on the mode, so this option is also cancelled. x1 is my minimum of x1, x2 and so on, but again we needed a mode of this, so this option is cancelled and only this option is my left behind. And how you can prove that? You can see from here, theta is greater than of mode of x. It may be x1, it may be x2 and so on. So since it is a greater than of this, I can written as maximum of x1, x2 and so on. So this is my right answer. Moreover, you can see from here your target is to maximize this f. When it will be maximum? When this because it's a denominator component, it must be minimum. So what is the minimum value from this interval? So you can see this is the MLE is lies between maximum of x1, x2 and so on, comma infinity. Now since we need a minimum value, so this is my minimum, so the right answer is here. Next one is, if xi's are my IID and it follows my normal distribution with the parameter mu comma 1. So what is the PDF of this? So 1 over 2 pi is a constant, so e raised to power minus half x minus mu here. So clearly say it is not free from the theta. Theta in this case is mu. So that means it is my unique MLE. Now our target is to find the mu. Mu is my mean. So that means MLE of the mu is my sample mean. Fine. So what is the, how many samples are there? N samples. So that means mu cap will be my x bar. Fine. Also one more thing is, mu is given as a greater than 0. Fine. So what does that means? That means mu cap should be maximum of 0 and x bar. Why? Because x bar is a sample mean. It can be negative, it can be positive, and if it is a positive, you can see how you can maximize this f. When it will be maximum? This f will be maximum when, because of this negative it should be minimum, but because of this negative it should be maximum. So that means it should be the maximum of 0 and x bar. Mu cap is the unbiased estimator. This is not always, because if maximum value is my 0, then it is not unbiased. So but he said it's unbiased. Sample mean is the sufficient, that is not a sufficient, does not exist, that is also, because how you can check for the sufficient? You must watch about my this lecture of this sufficient estimator. Okay, xi's are my random samples which are obtained from the normal distribution theta comma 1. So again, what is the PDF of this? E raised to power minus half x minus theta square. Again you can see it is not free from theta. So what does it mean? We will get a unique MLE. Again, how you can maximize this? When it will be maximum? When this will be maximum. Now again, theta is the part of a comma b. So when it will be the maximum? When this will be maximum? When theta will be b. So that means theta cap is my b. So that is my MLE of theta. So MLE of theta does not exist, cancel out. MLE of theta is x bar, that is wrong. Fine. MLE of theta is x bar only when this condition is not given to you. MLE of theta exists, that's correct, but it is not, that's fine. MLE of theta is the unbiased, that's wrong, because for the unbiased, what is that? This is a B, but it is not equal to theta. So that means this option is also cancelled. Right option is only C is my correct answer. Xi's are my random samples which are obtained from the uniform distribution theta comma 5 theta. So what is the PDF of this? If you write the PDF, it is 1 over 4 theta and it is not free from theta. Fine. So that means MLE is my unique. Now how you can find that? Now again it's a uniform distribution. Remember what I told you in this case is whenever it's a uniform distribution, your target is to make them as a positive. But in this case it is nothing is given to you, but it means that we can consider as a positive. Both have the same sign. So then what is the tips for you? If X follows my uniform distribution of this, then the MLE of A is ordered statistics 1, MLE of B is ordered statistics N. Fine. Now clear? Now since it is not free from theta, that means we will get as a unique MLE. Now according to these tips, what you obtained that theta, the MLE of theta will be x1 or 5 theta has the MLE xn, but he said x1 divided by 5. That's wrong because x only x1. From here you can see xn divided by 5. That is my here correct answer. That's the maximum of this. That's wrong because x1 is not the MLE. Fine. X1 is not the MLE, so that's why these two options are wrong. So B is my correct answer. Okay, look at this another one. Xi's follows the uniform distribution of theta and theta plus 1. So what is my PDF? PDF is 1 over B minus A, that is 1. And you can see it is free from theta. So once it is free from theta, it means MLE is not unique. Fine. MLE is not unique. Now whenever MLE is not unique, then we always think about the ordered statistics. Always remember that. Fine. So then how you can write that? You can look about the domain. Theta is x is less than of this. Now I can write this in terms of ordered statistics. x1, x2 and so on up to xn less than of theta plus 1. Now you can see from here theta is less than x1, and from this case I can say xn minus 1 is less than theta. So what is the MLE of theta is? It belongs to theta should be greater than of this number and it should be maximum of this number. Any number which lies in this closed interval is my MLE. Now look at the options. Which of the following is not the MLE? Does the x1 belongs to this? Yes. So yes, this is the MLE, but we need a not. So this option is cancelled. xn. Does xn belongs to this? No. So that means this is not the MLE. xn minus 1. Yes, it is the part of this. So it is not. Yes, it is the MLE, but we need a not. If this belongs to this, yes, that's a linear combination. You can say if you take the average of this, it will be here. So yes, this is the MLE, but we need a not. So that's a simple way you can solve. Okay, next one is Xi's follows the Poisson distribution with the parameter lambda. Then the log likelihood function. Can you write the PDF of this? E raised to power minus lambda, lambda raised to power x over x factorial. Fine. Then your target is to find the L. Now remember always, you can consider when you define the L, that is a log likelihood, consider only those terms, which involve x and theta. Theta in this case is lambda. Fine. Like which involves, yes, which involves of this parameters, or you can simply say which involves of. So now you can see I can consider this term. Fine. So what is that? Log is my this term. Fine. So I can return this is my n and this is my here. Now you can take the logarithm function. So it is a minus of this plus summation of xi is log of this. Now does it a constant? No, because this value will change. Summation of xi will always be the change. It is not a constant. Does it monotonic? So how you can check about the monotonic? I can differentiate this with respect to lambda. Minus of n plus summation of xi over this. Is it always greater than 0? Not possible, because it depends upon the n, and here it is always no. Is it always less than? No. So that means it is not monotone. Is it convex or concave? How you can check about the convex or concave? I can check about the second derivative. If this second derivative is my less than 0, then we call as a concave. If this second derivative is my greater than 0, we call as the convex. So what is the second derivative of this? This will be 0. This is my lambda square. Now we can see the denominator part is always positive. This part is always positive because it taken from the Poisson distribution. What is the range domain of the Poisson distribution? 0 to infinite. That means is a positive number. Sum is also a positive number. So this is less than 0 always. So that means whenever it's a less than 0, it's a concave nature. So the right answer is C is my correct answer. Okay, next one is x1, x2 and x3 are the IAD, and it follows the uniform distribution theta and theta square, where theta is my greater than 1. Now clearly say this number is positive. What is the PDF? It is theta square minus theta, and you can see it is not free from theta. Fine. It means MLE is my unique. Fine. You can see this case it is free from theta, that's why it is not a unique. But in this case it is not free from theta, is a unique. So what the shortcut takes, as I told you, this is the shortcut fix. Fine. So again I can use here, that means MLE of this is my x1 and upper limit is theta square will be x of n. What is the n is? Maximum number is 3. So I can say this is my 3. So first one is x1 square. That is not possible. MLE of theta. Can you find the value of theta from here? This is x3 raised to power half. That is a correct answer. Because it's a unique answer. MLE is theta is unique. So that's why this is there. And because this is not the MLE, this is not the MLE. So this option is cancelled out. x1. This is the MLE. This is the MLE. But you can see it's a unique answer are there. So it's a linear combination will not be the answer, because we will get as theta is the only value of x3 of half. So the right answer is B is my correct answer. Okay, look at this one. X1, X and Y are the independent Poisson distribution. X follows the Poisson distribution with the parameter lambda. Y follows Poisson distribution with the parameter lambda plus 1, where lambda is my positive, is the unknown parameter. Based on the single observations, this MLE of this. Now, what is the PDF of the X? E raised to power minus lambda, lambda raised to power X over X factorial. What is the PDF of the Y? E raised to power lambda plus 1, lambda plus 1 of Y divided by Y factorial. Now since they are my independent and this problem is my two-dimensional random variable, so can you find the PDF of x comma y? Because they are independent, I can return this is fx into fy. So I consider only those terms which involves lambda and x. That means I can ignore the denominator part. So if I use this part, this here into lambda raised to power x, lambda plus 1 raised to power y. Fine. Now, because it is only based on the single observation, so that's why there is no need to write the product form. Now, what you can do, you can simplify this. It is e raised to power minus 2 lambda of this. This is lambda raised to power x of here. Now your target is to find this. I can call as log of, this is L. This value will be minus 2 lambda plus 1 plus x log of this plus y log of this. Fine. Now, because it's a function of the x and y both, so my derivative with respect to x, partial derivative with respect to y should be 0. Then partial derivative with respect to x, x over lambda, partial derivative with respect to y, y over this will be 0. Fine. And the value of the x and y are given as a 2 and 3. So I can substitute here. What is the value of the x? X will be my 2 over lambda, y is my 3, which is 0. So since this number can never be 0 because lambda is my finite, so I can take about the option. Let's say 2 over 2 1 and 2 over 3 is 1. That's the fine answer. Is it 3 satisfied? 2 over 3, 3 over 4, which is not satisfied. 2.5, 2 over 2.5 and 3 over 3.5, it is not satisfied. Similarly, 3.5 not satisfied. Right answer is only A is my correct answer. Okay, look at this another one. x1, x2 and xn are the IID random variable samples satisfying the following regression equations. xi is alpha zi plus ei, where zi's are my fixed numbers and ei's are my IID with the normal distribution. Then the MLE of sigma square is my MLE of alpha. This is given to you and your target is to find this value of this. That means my target is to find the MLE of alpha. Fine. And that's very simple. You can remember that. If you remember that, if you have the line of y is equal to bx plus c, fine, that is my regression line. What we call as this b, this is the coefficient, this is the regression coefficient y on x. What is the formula of this? Is correlation coefficient sigma y over sigma x. Fine. Or you can also write this in terms of the covariance x comma y divided by variance of x. That is the same meaning, because we all know R will be covariance divided by sigma x into sigma y. If you substitute R at here, sigma y will be cancelled out, sigma square will be here. Now that means alpha. What does it mean? Alpha will be my here. So covariance, what is the x? X is my here. If you compare them, x is my z, y will be my left hand side, y is my x, divided by variance of the x. X is my independent variable. So in this case, it is my variance of z. So that's the answer. Now how you can write this component? Let me clear this screen. So how you can write that? This is expected value of zx minus expected value of z, expected value of the x, divided by expected value of the z square minus expected value of z whole square. Now if you look about the options, all have the center 0. That means mean is my 0. So this component is my 0, this is my 0, this is my 0. How you can write that? xi, zi. How you can write that? This is zi square. This is the MLE of alpha. It is a xi square, but we need a zi square. It's a n. It's a n. You can see the same expression I have obtained. So that's a simple regression equation like y on the x. Okay, look at this another one. Xi's are the IID random variable samples which are follow uniform distribution of the theta and 2 theta. Fine. Then the MLE of this. So firstly we will identify whether it's a unique or not. What is the PDF? Theta, and you clearly say it is not free from theta. So that means we will get MLE as unique. Fine. So what does it mean? This has MLE lower limit, this has MLE x of upper limit. That means you can see from the lower limit is a x1 and from here it is xn over 2. Clear? Now x1 is also there, this number is cancelled because we got as xn divided by 2. This number is also cancelled out because it is not the linear, it is not the average of this. Now out of these two, which one is satisfied? You can see about here. What is given to you? F is 1 over theta. Fine. So when it will be maximum? When this term will be minimum. Fine. When this term will be minimum. So that means if you look about this term, if you look about here, this is xn less than of 2 theta. That means theta should be less than of this, less than of this, less than of this. So what is that theta cap? Should be xn divided by 2 and x1. Fine, because this is the upper limit and this is the lower limit. Now when it will be maximum? When theta should be minimum. So this number is my minimum. Fine. So my right answer is, this is the correct answer, this is the wrong answer. If this function is my independent of the theta, then this is also the MLE, this is also the MLE, and any number which lies in between them. That means the linear combination of this, that means alpha times xn over 2 plus 1 minus alpha times of x1 is also the MLE if this is free from theta. Okay, look at this another one. If x and y are the independent random variable, each follows the normal distribution. X follows the normal distribution with the mean theta, variance 1. Y follows the normal distribution with the mean 3 theta, variance is 1. Then theta cap is the MLE of theta based on the x and y. Okay, can you find the PDF of this? That is e raised to power minus half x minus theta. PDF of the y will be e raised to power minus half x minus 3 theta. Fine. So can you write the joint density function? Because they are independent, so I can written as product of this. So half I can taken as a common, x minus theta square plus x minus here. Fine. Now I can define the L, that is taken as a log of L. Say this is my L. Fine. So log of L will be minus half of x minus theta square plus it is my y. This is for the y, it is a y minus theta I square. Now you can take a derivative with respect to theta as my 0. So it will be, this half will be, I can cancel out this of negative, and from here it is a twice y minus 3 theta into minus 3 theta is 0. So minus of 2 I can cancel out, it is x minus theta, minus of 2 will be cancelled out, so plus 3y minus 9 theta is 0. So it means x plus 3y over 10 is my theta, and this is the MLE of theta. Fine. Then so this is my theta cap. Now the question is whether it's a biased or unbiased. So we can check about this. What is the expected value of this? 1 over 10 is outside. What is the mean of the x? Theta. Mean of this is 3 into 3 theta. So what is the answer of this? 9 plus 1, 10. 10 over 10 is theta, which is same. So that means this is my unbiased. So biased option cancel. Then your target is to compute whether. Now your target is to compute the variance. So what is the variance of theta cap? So 1 over 100 is outside because they are my independent. So what is the variance of the x1? 1. Variance of 3, that is a 9 into variance of y. So what is the variance of y? 1. So 9 plus 1 is 10 over 100, that is 1 over 10 is my. So it's a 1 over 100 cancel and it's a 1 over 10. So the right answer is B is my correct answer. Okay, PDF already is given to be my this. Fine. So again you can see xi's are my random sample which follow this distribution, that is basically a uniform distribution of k theta and k plus 1 theta. So clearly say it is not free from theta. So that means you have a unique MLE. So how you can find the unique MLE? So again a simple, how you can maximize them? So it means your target is to minimize this. So I can start from this range. I can write this as the ordered statistics x1, x2 and then xn is less than of k plus 1 theta. So can you find the value of theta from here? It will be x1 over k, and from this it will be xn over k plus 1. So that theta cap should belongs to xn over k plus 1 comma x1 comma k. Now since it is a unique, and what is the value of the unique is that give you the minimum value. So this is my minimum because it's an interval. So this is my minimum. Xn over k plus 1 is the MLE of theta. This is already this is also the MLE, but if it is not a unique, xn is not there, so this is cancelled, this is cancelled. So the right answer is C is my correct option. Okay, next one is if x1, x2 and xn are the random samples which are obtained from the uniform distribution of theta and theta plus 1, then the number of the MLE estimators. Can you find the PDF of this? PDF is 1 over 1 and it is free from theta. So once it is free from theta, what is the meaning of that? MLE is not unique. Fine. So once MLE is not unique, how many MLEs of this? It has infinitely many MLEs. So the number of the MLE is my infinite. And if you want to calculate what are those MLEs, you can see from here. So theta, this is my range of this. I can written as x1, x2 and up to xn. Fine. So from here I can say this number is my here, and from this it will be xn minus 1 theta. So this is belongs to xn minus 1 comma x1. Any number which are belongs to this closed intervals are my MLEs. So how many numbers are there? They are infinitely many. Or you can also write this as alpha times xn minus 1 plus 1 minus alpha times x1, where alpha belongs to the, that is a convex linear combination of this. So you can see it has infinitely many distributions. So that means this is the right answer. You can also watch this as I told you, you can watch this MLE estimators. You can see again more than 20 examples in this lecture also from the GATE and IIT JAM with the same pattern. I hope you can like, subscribe and comment on my video too. You can scan and join my WhatsApp group if you are interested for this kind of the more questions. We will see the next lecture on the different topic. I hope you can like, share and comment on my video. Best of luck students. Happy learning.